IPCR symposium, we can cover them. So thank you. And as we begin, we're starting our first morning session with Dr. Etzioni. Let's see if I can get out of here. Hopefully I can. Here we go. So Dr. Etzioni is a researcher here at Fred Hutchinson Cancer Research Center. She's really internationally known for her work around prostate cancer screening, the use of PSA, various other outcome approaches. She's reanalyzed all the big screening studies that used PSA to demonstrate whether there was or wasn't a change in survival endpoints. And so we'll hear from her today about really the latest around screening. Ruth?
Thanks, Pete. Good morning, everyone. This is always such a pleasure doing the symposium, and I hope I have a little time, but I hope that if I don't get to your questions, that we'll be able to get to them in the question and answer. So I'm sure that everyone here has heard the term evidence-based medicine. All of our policy panels that are tasked with making recommendations for early detection and screening are tasked with developing evidence-based recommendations. But the truth is that when it comes to developing recommendations for screening, there are many gaps in the evidence. And our lab, which is a group of biostatisticians, focuses on trying to fill in those gaps. Today I'm going to try to give you a sense of where we're at in prostate cancer screening, while at the same time telling you about several of our ongoing projects. So in a way, we're kind of in a bit of a holding pattern, waiting to see what happens with the fallout from the U.S. Preventive Services Task Force's D recommendation against prostate cancer screening. And I showed these figures last year. The first one is a survey of prostate cancer screening rates by age. The gray, with mouse here, yeah, the gray here, the gray curve here is the most recent survey by age, showing men's use of screening. So it's dropped a bit. And here is prostate cancer incidence that Pete showed. There was a big drop-off in 2012. We were about 3 years behind. We get prostate cancer rates 3 years. From 3 years ago are our most recent. The 2014 rates are going to be coming out next month. And so you can see this drop-off. You see this big peak when screening first came in, and it was as men rapidly adopted PSA screening. And then there's always a drop when an early detection intervention is rapidly adopted, as the pool of latent cases becomes depleted. And then what's interesting is that you see it didn't go all the way down, but then it kind of started to go up again and then came down again. So what we think was happening over here was more extensive biopsies. We know that the original 4 to 6 core biopsies did not detect all prostate cancers. And so there were several years when biopsy technology changed, and so that might have led to the second peak. And it's likely that some of this drop, and it's been commented on a lot, is due to this drop in screening. Now, we've tried to kind of map out what would happen if men followed the D recommendation. This is a graph of advanced stage prostate cancer incidence. The black curve is observed rates from the cancer registry over time. And just when PSA screening came in the years after, you can see this dramatic drop in advanced stage cancers at diagnosis. And we've calculated that the majority of that drop is likely due to screening. Can't quite match it. And if we had to discontinue screening, we would see a big rise pretty soon in the incidence of advanced stage prostate cancer. So we are eagerly waiting to see what happens with the 2014 data when it comes out in a month's time. Now, what would happen to deaths? So here we have the mortality curve. This is the curve really that Pete showed in black, and that big drop in prostate cancer deaths. And we spent a lot of time trying to understand how much of that drop was due to screening based on what we know about screening patterns, and how much of that drop was due to better treatment, particularly for localized prostate cancer, improvements in surgery in the early part of the PSA era, and the use of hormone therapies with radiation therapy really contributed as well to this drop. And yet there are other factors that we think also contributed that we think might be related to the use of PSA after diagnosis and earlier detection of progressive disease and much earlier application of secondary and salvage treatments after diagnosis. And that's very difficult to model, and we're working on seeing if we can model that and explain the drop. But the net upshot of this is that if men do follow the D recommendation, deaths will increase, but they won't increase back to the original levels because of these other factors that have contributed to the drop. Now, while we're in this holding pattern, right now as we speak, the U.S. Preventive Services Task Force is revisiting its recommendation. We have begged them to let us help them, but they're really, again, tasked with using the evidence, and the evidence comes from the two largest screening trials, the European trial, ERSBC, and the U.S. trial, PLCO. And that's what their original recommendations were based on, the trials, and they're continuing to look at updates of the trials. And our kind of filling in the evidence gaps, which uses mathematical and statistical tools, is a step removed from the classical definition of evidence. And it's not quite at the point where they, as a policy panel, are ready to use it. I will say that we've worked with practically every other policy panel: the American Cancer Society, the National Comprehensive Cancer Network, the American Urology Association. So what I'm going to show you now is some work that we've done revisiting the trials. So just to show you what the trials look like, right? This is the European trial, the updates from the European trial. And you can see that screening really seems to have had a benefit. This is prostate cancer deaths, cumulative over time. But in the US trial, there was no difference. In fact, the screening group had slightly more deaths than the control group, prostate cancer. And the reduction in deaths was really quite significant, at least a 20% reduction in deaths in the European trial. And I'm sorry, I'm just looking at this and I'm realizing I updated my slides, and I'm not sure if these are the updated slides or not, but I'm going to make it work regardless. This is the reduction in deaths. So this is the deaths in the screen group relative to the deaths in the control group. So if it's less than 1, it means that there were fewer deaths in the control group. So 0.79 means there were 21% fewer deaths in the screen group than in the control group. So that reflects the lower deaths in the screen group. And in the U.S. trial, it's not less than 1. It's slightly more than 1. It means there was no drop. It was a slight increase in deaths, but this was not significant. So when the U.S. Preventive Services Task Force was looking at these results, it was equivocal, and the result was a D recommendation. Also, the absolute numbers in the trials of lives saved were low. That's the second row here, the numbers of lives saved per 1,000 men screened, and they felt that this was just not significant enough. And we have done a lot of work and published and spoken a lot about how you can't look within the trial. You have to imagine that you're actually applying the trial results to a population over a much longer period of time, and these small numbers are going to be much higher in the population. So this is recent work that I'm going to tell you about, and actually it's the first time I've presented these results, and they've just been accepted for publication in the Annals of Internal Medicine. It's going to take me a few minutes to explain what we did, and I really hope this is clear, and I welcome any questions. So the main point of what we did was that the reason why the U.S. trial did not give a result is that there was a lot of screening on the control arm. It was not a trial of screening versus no screening. Oops, Okay, I can still talk, and hopefully our AV people will fix this. Okay, I guess it's okay. I'll still, okay, great. There was a lot of screening. The U.S. trial started in 1993, and screening had already started in the U.S. And 74% of men on the control arm of the U.S. trial were screened at least once, and half of them were screened every year. So this was really an explanation. We understand, and even the investigators of that trial do not submit it now as screening versus no screening. But what are we to do with that information? And can we somehow put the results of these trials together in a way that recognizes that it is not screening versus no screening? So here's our idea. Our idea is that we have two trials, and each of them has a screen and control arm. But instead of comparing the screen with the control arm as is usually done, let's consider comparing all of the arms against an unscreened population prior to the U.S., prior to the introduction of PSA screening. So we're going to compare all of those arms with the U.S. prior to the introduction of PSA screening. Now, it turns out that on each of those arms, not only in the U.S. trial, but even in the European trial on their control arm, there was a little bit of screening. There was some screening on every arm. And we can't really talk about screening versus no screening because the protocols of the trial were different. In the U.S., there was screening every year, and a positive test was a PSA of 4. And in the European trial, there was a test every 2 to 4 years, depending on the center, and the cutoff was 3. And the compliance with biopsy in the U.S. was much lower than in Europe. So in a sense, the amount of screening and diagnostic, we can say the screening and diagnostic intensity was different on every arm of every trial. So the first thing we do is we develop a proxy for this screening and diagnostic intensity, and that it's more or less interpreted as the amount by which the prostate cancer diagnosis is advanced in each arm. So how much earlier are we going to be able to detect on each arm, based on how much screening and compliance and biopsy was going on. And the numbers are here. From the PLCO, that's the US screen group, it's about 4.1 years. And in the control group, it's 0.9 years, earlier diagnosis relative to the unscreened population. All right, so we have this difference in screening and diagnostic intensity. And then we statistically correlate it with the reduction in prostate cancer death, with the screening benefit. And we find that the screening benefit on each arm now, relative to the unscreened population, is very correlated, very dependent on this diagnostic and screening intensity. And once we account for that diagnostic and screening intensity, there is no difference in the benefit in the two trials. The screening and diagnostic intensity is very different in the two trials and very different between the arms of each trial. But once we account for that, there is no trial effect. So we actually conclude from this that the trials are very consistent, so long as you don't do the normal analysis, and so long as you actually go beyond the data and recognize that you have a way of understanding why there was a difference between the results of the trials. So the conclusion of our paper is that the trials are actually much more consistent than the U.S. Preventive Services Task Force or anyone else reading the empirical data would conclude. And if you look towards the lower part of the slide, if we translate that, if we say screening benefit depends on this screening and diagnostic intensity, and we look at the screening and diagnostic intensity on the screened arms of each trial, we conclude that actually screening in the European trial was associated with a 28 to 35% reduction in mortality. And in the US trial, because there's benefit on both arms of the US trial, it's over 30% reduction relative to no screening. And the reason there's a range there is because we've worked with other groups doing this work, 2 other groups modeling, and our results are very consistent, so we have a robust result. And so This is, we just heard this week that this is now provisionally is accepted to the Annals of Internal Medicine, and I'm very happy to present these results to you. So I've got just a couple more minutes, and I want to just tell you about a couple of other projects that our lab is working on. So I was very delighted to attend the annual summit of the Prostate Health Education Network, an advocacy organization for African American men in Washington, D.C. last year. And I am utterly committed to trying to disseminate this work that we've done that shows that African American men have a very different profile of prostate cancer than the general population. Now, we know this from incidence and mortality curves. We know that prostate cancer have more than 1.5 times the incidence and double the mortality of prostate cancer than the general population. But why is it? Is it just because they have more disease? Is it because they have worse disease? So what we've done is, again, we've tried to go beyond the data and try to learn about what is the difference. And again, with 3 different models, I'm showing the results from our model, we've concluded that they have more disease and they get it earlier and it progresses faster to a metastatic state. And these are the numbers. The lifetime risk of not of incidence, what you see in the data, but of actually having onset of a prostate cancer tumor is 45% in black men relative to 29% in white men, in the general population, I'm sorry. And the lifetime risk of having a progression to a metastatic tumor is 10% given that you've had onset, 10% of those tumors will progress to metastatic state in black men versus the general population. And so we believe that this mandates different screening for this vulnerable population that is not average risk. And the U.S. Preventive Services Task Force did not provide a separate guideline for this population, and we're trying to change that. This is where we have an evidence gap. Why is there an evidence gap? Because there is no screening trial in African American men. We have to use what we know about how they're different to project out to the consequences of different screening approaches for this population, and that's what we do in our lab. So in the last minute, I just will turn to talk about the future of screening, and Pete talked about risk stratification, and Pete is telling me not to talk about this because I'm out of time. So hopefully you'll hear more about this. Some of you may have heard about a baseline PSA for men in their 40s, predicting risk in the future. I'll just tell you this is based on a Swedish study of stored blood samples. So we first want to check that this really pans out and we can validate these results and then project out for our policy panels of whether it's worthwhile screening all men in their 40s once and then partitioning them into high versus low risk and doing different screening, or maybe screening everyone every 2 years and what are the differential consequences of those. And trust me, there's no trial that's going to look at that. So again, we have to use our methods. And so I will end here. Do we need a better test? I think PSA is a very efficacious test. And in past years, you've heard me speak about how we should be using it smarter. And here are some of the things that we've come up with. And so in the end, it's wonderful that you're all here because it's an opportunity for you to